Okay, we'll work through homework problem 4.110. So in our problem here, we have a number of things going on. So we have this pipe, it's coming out from the wall, comes towards us, down, towards us some more, and then at that end we have a force acting. And we can see that that's acting out and down from that location. So there's some y component, x component, and z component to that. So we're looking at this and we need to find the equivalent resultant force and a couple moment to make this an equivalent system, and that both the force and the moment will be acting at point A back here where it's attached to the wall. So our first step is to break down find the components of F. So we can put that in IJK notation. Components. And then we will find R, so the position vector R from A to that point where that's located. And then finally we'll find R cross F. Alright, so let's start with step 1, finding the components of this force here. So if you look at that, you might see right off the bat that F sub z, the z component, is going to be negative 80, right? So it's going down. Positive z is up. It's up. So z, this is going down. It's going to be 80 sine of 30. So this part is our vertical component. Then we might also recall from, I think it was chapter 2, f prime is going to be 80 cosine of 30. So the other component, so that's what's left here acting at this point. And f prime is going to be the x component plus the y component. So f of x then it's going to be 80 cosine 30 degrees. So that component there. So that gets us up to this section here. And then we're really looking for this component. So that's fx. This is our fz here. And then this larger section here is going to be our fy. So our fx is 80 cosine 30. Oh, I should have left it there. Times sine of 40, right? So we're getting that part times sine of 40. So that's what we have there. And fy then is going to be 80 cosine of 30 times the cosine of 40, right? So that's the cosine of 40. So if we find each of those components, f of x then is going to be 44.53 newtons. So that component there. F of y is going to be 53.07 newtons. So again, that was just this evaluation of this numerically is 53.07. And finally fz, our negative 80 sine 30 is going to be negative 40 newtons in the down direction. So let me scroll and then we'll express this in Cartesian vector notation. So f then is going to be our x component, so 44.53 in the I direction plus 53.07 in the j direction minus 40 in the k direction, and the units there are newtons. I should have made that a curly bracket. So there's our first part. There's our equivalent force. Alright, and then finally, or not finally, but the next step, step 2, is going to be to find R. So we see here we're going 400 millimeters or 0.4 meters in the y, then 0.3 in the x, negative 0.2 in the z, and another 0.25 in the x. So we can just take all of those, or we could take this component here and subtract off that, our A coordinate system. So in x we went 250 plus 300, so r 0.55 I, that's positive because we're going in the positive direction. Y we went, what's that, 0.4, yep, so here's our 0.4 in the y direction, again in the positive direction there, plus 0.4 j, and then we actually have a negative in the z direction. I think it was 0.2 if I recall. Coming here, here's our z. So we go minus 0.2 k, and that's meters. And then we need to find mr, which is r cross f. Resultant vector. So it's going to be I, j, k. Our r components here, 0.55, 0.4, negative 0.2, and then our f components, 44.53, 53.07, and negative 40. And I'm going to copy down my first column here to make crossing for my j a little more convenient. Alright, and then just give us a little space here. I'll scroll down. So that equals I times, we're going to cross this area. So we're going to have negative 40, put another parenthesis there, times 0.4 minus negative 0.2 times 53.07. That's our i's, plus j, so I'm going to cross here and subtract that. I should have put a negative there. Negative 0.2 times 44.53 minus 0.55 negative 40, and then finally our k component plus k times, what do we have, 0.55 times 53.07 minus 0.4 times 44.53. And if we do all the math there, so this is a negative number, this is a positive number. Oh, sorry, let's see, we have 16, this becomes 16 plus about 26. What do we end up with? Not 26.